Good example to all my friends who are watching this video. Today I am going to continue on my part the Phasor diagram of Schering bridge. So we are going to take I1 as a reference line, and we should know that the deflecting current in the bridge ID is equal to 0, which will give us I1 equal to I3 and I2 equal to I4. Now we extend the line of the reference line by I1 R1, which we know that the voltage in the capacitor lags 90 degree with current, so we draw a line downwards, which is I1 by omega C1. So for E1 we should add C1 and R1, and in Phasor diagram we use the parallelogram law, which is E1 equal to E2, where we get E2 as I2 divided by omega C2. And here we also know that the current leads 90 degree with voltage in the capacitor. Now since I1 equal to I3, we get E3 is equals to I1 times R3, and we extend the line on the same face in the Phasor diagram. Now since E3 is equal to E4, the current here I4 is divided into two parts. The first part is IC and the second part is IR. So for first part, IC is going through our capacitor. So E4 for first part we get IC divided by omega C4, and the current, we know that it always leads the voltage by 90 degree. So we draw a line here. Next, so for IR, the current IR, it is going through a resistor, so it is a IR. R4 is a resistive voltage, so IR will be in the same direction, so we get IR here. So in the next arm we know that I4 equals to I2, so it is equals to IC plus IR. So we know that the total phasor sum is equals to E equal to E1 plus E3 or E2 plus E4. So we draw the phasor sum in by using the parallel line, and we get the final Phasor diagram of the Schering bridge. So thank you and stay.